The global situation today is well known. Our growing human family has growing needs, crucial needs for the field crops that provide food, fuel, fiber, and feed. Another reality, these needs can be met only by you. You, the agronomists and growers who face greater and greater demands to increase the quantities and quality of crops. So imagine all the kinds of field crops that could grow here, and then ask yourself, for every kind of field crop, how can you best use fertilizer to get the best possible results? And within the context of your cropping system, how can you also help to achieve another critical goal, economic, environmental, and social sustainability? Let's find out. For all kinds of field crops, for the full range of production farming practices, and for the most effective and efficient use of fertilizer, we're going to explore what the scientific staff at the International Plant Nutrition Institute and the fertilizer industry and agronomic community recommend. The right way to grow. 4R Nutrient Stewardship. The right way to grow uses 4R Nutrient Stewardship, the right fertilizer source, applied at the right rate, at the right time, and in the right place. These four central components, when used together, form a unified system of crop fertilization. Before we explore an overview of some of the more important best management practices related to the 4Rs, remember, determining what is right also depends on site-specific factors, such as the crop, soil, climate, economics, labor supply, and logistics. The specifics will be different for each site, crop, and grower, but the principles are the same for all. We start with the right source. The goal? Determine the correct and best fertilizers to use to achieve balanced fertilization. For crop development, there are 17 essential nutrients. Carbon, hydrogen, and oxygen come from water and carbon dioxide. The soil provides the macronutrients, nitrogen, phosphorus, and potassium, the secondary nutrients, calcium, magnesium, and sulfur, and the 8 micronutrients. Whatever the specific balance of nutrients, they must be in forms that the plants can take up. You can select nutrient sources that will be immediately available to the plant, or that once in the soil will convert into a plant available form when the crop needs it later in the growing season. 2 more best practices help make sure that the nutrients will actually be available to the plant. Use certain fertilizers only in conditions that will not increase losses. And use fertilizers that suit the soil's physical and chemical properties, such as texture, pH, and soil moisture. As an example, consider the surface application of urea. If this fertilizer is not incorporated or followed soon after application by rainfall or irrigation, there can be gaseous losses of the nitrogen. These losses are greatest from moist soils in hot, dry conditions and in fields with heavy residue cover. What do you do when the surface-applied fertilizer cannot be incorporated? Consider other options to prevent nitrogen loss. Select a low-volatility nutrient source such as ammonium nitrate, or use a urease inhibitor or a controlled-release fertilizer. To summarize the right source, ask yourself, what nutrients does the crop need, in what plant available forms, for what kinds of field conditions, and in what balance? Your answers will determine the first right of 4R Nutrient Stewardship. Once you've determined which fertilizers to use, the next goal is to determine how much fertilizer to use, the right rate. Crop nutrient uptake varies regionally, and that information is often available. As always, the first consideration is the crop. How much of which nutrients does it require? Start by assessing what the plant's nutrient demands will be. The nutrient requirements in one season depends on the crop yield being targeted and on the desired crop quality in terms of nutrient content. The next question, what quantities of those nutrients can the site itself provide? First, test the soil. Soil tests will provide the basic information. Analysis of plants that grew in that soil can provide more good information. And nutrient response experiments can provide actual yield and quality data. Assess the nutrient contributions from all other available nutrient sources, such as crop residues, green manures, animal manures, composts, biosolids, irrigation water, and atmospheric deposition. The difference in the quantities of the nutrients that the crop needs and the nutrients that the site can provide is a good approximation of the quantity of additional fertilizer that's needed. But to optimize the fertilizer's results, take two more factors into account: nutrient use efficiency and seasonal variations. Nutrient use efficiency is a major factor in defining the fertilizer rate needed. It's generally expressed as a ratio of fertilizer inputs to crop outputs. The reality is, effectiveness of fertilizer inputs is often adversely affected by inherent sinks and loss mechanisms that exist in every field. Nutrient use efficiency will also vary according to site-specific factors, including weather, soil type, and cropping system. That's why adjustments for efficiency are often included in the rate recommendations provided by universities and professional consultants. Remember that fertilizers are applied to increase the overall performance of a cropping system. Nutrient use efficiency is just one aspect of that performance. The point is, with good fertilizer management practices, nutrient losses can be minimized. One practice to guard against? Habitually using the same rate every year. You see, just as different field conditions affect rates, so does the weather. Each year is different in terms of precipitation and temperature. That's why it's good practice to determine plant nutrient status in season. Plant tissue analysis, for example, can help you deal effectively with the year-to-year variations in yield potential and nutrient requirements. Those are the fundamentals for determining the right rate of what is now becoming a unified system of nutrient stewardship. To make the right way to grow even stronger, let's explore the right time. When is the best time to apply fertilizer? Again, there is no one right answer, but there are best practices to follow. Nutrient supply must be synchronized with the crop's nutrient requirements. Assessing the timing of crop uptake depends most on the planting date and the growth characteristics of the plant. Data that show each crop's nutrient needs are available from the International Plant Nutrition Institute and other organizations. The point in all situations, determine the plant's nutrient needs and plan fertilizer applications before the cropping season begins. Then, make sure that the nutrients are in the soil when the plant is going to take them up. Loading the soil too early leaves high levels of nutrient just sitting there with the potential to be lost. For example, changes in the weather can cause nutrient loss. In all regions, temperate and tropical, heavy rains and flooding are likely to cause losses of soil nutrients. If this happens, follow-up applications may sometimes be necessary. The best practice? Minimize the potential for loss. Apply fertilizer before the crop needs it, but avoid having too much fertilizer in the field when the plant doesn't need it. In summary, base your right time decisions on the best assessments you can make and on the realities you must deal with. And now, the right place. Exactly where should the fertilizer be applied? A main issue guiding placement decisions is the mobility of the fertilizer nutrients in the soil. Two examples. Nitrogen is highly mobile with water, so it moves to the root system. Phosphorus and potassium are not very mobile, so roots must grow to the fertilized zone. With this in mind, let's consider the ramifications for the crop, the fertilizer, and the crop system. The roots of annual field crops explore the soil progressively over the season. This means that fertilizer placement should ensure that nutrients are available where and when needed. An example, corn in soil that tests low in phosphorus. Here, the band placement of phosphate fertilizer can help ensure sufficient nutrition for the young seedling and increase yield substantially. Another right place best practice, take into account that different areas of a field may have different fertilizer requirements. The grower's experience with crop growth and yields can often locate the fertility variability, as can GPS-based yield mapping, soil surveys, and grid soil sampling. Then, using these data, you can establish management zones that make site-specific decisions that will ensure that each area in the field is appropriately fertilized. For fields with slopes that are prone to runoff, it's important to limit the possibility of fertilizer migration. For example, in order to ensure that phosphorus stays where it's needed, sufficient residue should be maintained at the surface to prevent runoff. The fertilizer should be placed beneath the surface, or site-appropriate tillage used for incorporation. Those are the fundamental best management practices of the right place. Notice that the right place can also involve the other components. In fact, each of the 4 R's is directly related to the other 3 in at least one way. That's what makes the right way to grow unified and effective. After all, it's 4R nutrient stewardship that can help meet the economic, environmental, and social goals of sustainable agricultural systems. Systems needed to provide adequate food, fuel, fiber, and feed for the growing human family.